Welcome to the 4Dudes channel, where you have chosen to watch 4Dudes talk about math and physics so that you don't fail the IB diploma program. As always, you can skip to a specific section of the video by clicking into the description right below this video. Now let's get into the content. We will be beginning with the SI units. The SI system has 7 fundamental units for the 7 fundamental quantities. From these 7, most of the physics formulas are derived from them. Kilogram is for mass, meter for length, seconds for time, amperes for current, kelvins for temperature, moles for the amount of a substance, and candela for luminous intensity. Quantities like speed, acceleration, and newtons are units derived from these 7 fundamental ones. Here's a list of other derived units that will be important to the IB physics exam. With the units in mind, let's talk about the numbers that go before the units. This brings us to significant figures. Significant figures are also known as sig figs, and sig figs are pretty easy. In the number 5406, there are 4 significant figures. In 60,891, there are 5 sig figs. Any zero that's on the left of a non-zero is insignificant, so in 0.345, there are only 3 sig figs. In 0.034, there are only 2 sig figs. Zeros on the right are significant as long as they are on the right of a decimal and a number. For example, 0.034500 has 5 significant figures because the zeros that come after count, but the numbers before the non-zero don't count. Another example is 400, but in this example, it's only 1 significant figure because there's no decimal point after the 2 zeros. In this case, in order to write it into 3 significant figures, we would have to use the scientific notation, such as illustrated here. Applying it to a question, let's say that the question is telling you to find the product of 12 and 6.7229. You would get 80.6748 as the actual answer. But for subjects such as physics, it would be unacceptable to keep those extra decimals because we are not sure that those decimals exist in the calculation. So for a test, you would write 81 as the answer. You need to look at the value with the lowest significant figures, then base your final answer on it. If the lowest is 2 sig figs, then your final answer needs to be in 2 sig figs. And just a quick FYI, in multiplication and division, you give the answer to the lowest significant figure. In addition and subtraction, you give the answer to the lowest decimal place. Now we move on to metric multipliers. Metric multipliers are used to express small or large quantities in terms of the units related to the basic ones by a power of 10. A familiar example would be using metric multipliers to measure distance. When measuring distance, the different prefixes revolve around the meter, such as millimeters, centimeters, meters, and kilometers. This makes writing values convenient as the prefix determines the size of the value while enabling us to keep the numbers to a sensible amount of figures. For example, instead of writing 10 million millimeters, we can write it as 10 kilometers. Here's a list of the prefixes that are associated with each metric multiplier. Moving on to estimation by graph. This is our last part of 1.1. Sometimes the exam might give you a graph and call for you to estimate the area under the graph to find the value for something. In this example, we calculate impulse, which is force multiplied by time. To do so, we estimate how many squares the graph makes up. In this example, there are 26 complete yellow squares under the curve. There are more partial squares totaling to about 4 full squares. So we have a total of about 30 full squares under the curve. Each curve has an area of 2 newtons times 1 second, which equals to 2 newton seconds. So our answer in this case is 60 newton seconds approximately.